Good morning to all. In this video, let us discuss how to sort the given number in the ascending order. An array of numbers are given and this array is arranged in such a way that the first number of the array is indicating the total number of elements in the array. Because we are going to write the program in assembly language program in 8085. So therefore, knowing the array element, number of element in the array is very useful for us to write the program comfortably. Fine. Now let us see that in the memory location 4200, 06 is stored, followed by 6 different numbers arranged in a random order. So as usual, we are initializing the memory pointer 4200. We are moving the count value to the B register, and as we have seen in the previous program, for 6 numbers only 5 comparisons are required. So we are immediately decrementing the count value by 1, and then we are incrementing the memory pointer to point the next number. At present, so the memory is pointing this value. This is pointed, 0.02 is pointed by the memory. So HL is having HL value. So what is the value of HL now? HL is 4201. Okay. So now what we are doing is we are pushing HL. We are push H means HL is pushed to the stack pointer. So stack pointer is initialized as 00 because there is no initialization. So it becomes a 00 now. So what will happen to the stack pointer we will discuss. So once push H is pressed, L value is 01 now. 01 will be stored here, and then 42 will be stored in FE, and then we are pushing B. So B is having a value of 05. So BC is pushed actually. So D becomes 00, and then it becomes 05. Because the B is having a value of, this is the value of B. Actually this is so actually this is the value of L, this is H, this is nothing but C, this is nothing but the value of B. This is how the stack pointer is storing the data. Okay. So there is a significance for that. So we have to retain this address for the next comparison. Therefore, it has been temporarily stored into the stack pointer. Now we are calling the subroutine. So subroutine is available here. The accumulator is copying from memory pointer. So now accumulator is equal to 02. So we are incrementing the H. So H is pointing, that is, the memory is pointing the 05. So 02 and 02 and 05 are, it is not point, it is 02 and 05 are compared, compare M. So jump carry. So when we are comparing 2 and 5, that is 2 is available in the accumulator, 5 is available in memory location. So definitely carry is generated. Whenever carry is generated, we are going to loop 3. Okay, we are decrementing B. So the B value is now how much? 5. So now the B is equal to 0, 4. Jump no 0. B is not become 0. So continue to loop 2. So loop 2 means we are M is become 0, 1. Now 01 is available in M, and 02 is available in the accumulator. So now it is compared. Now carry is not generated. When carry is not generated, it will go to the next instruction to be executed. So here what we do is we are swapping between the memory and accumulator. So we need a temporary register to store that. So D register is equal to 01. And then M is become 02, that is the content of accumulator. So accumulator becomes 01 from the D register. So now accumulator is equal to 01, and m is equal to 0, 2, which means that this is replaced with 0, 2. If 0, 1 is replaced with 0, 2, which means this is 4200, 201, 202, 203. That is 4203. 4203 is equal to 0, 2. So whenever we are changing the memory register value, automatically the memory location indicated by the HL register pair is equal to the M value. So it will change into 0, 2. Now what do we do is, we are just comparing. Again we are decrementing. Now it is become 0, 3. And it is not at 0. It is going back. And 0, 9 is compared with 0, 1. Now carry is generated, there is no swapping, and we are decrementing. Now it becomes 0, 2. So now it is 0, 3. Again 0, 1 and 0, 1 and 0, 3 is compared, carry is generated, no swapping. Again it becomes 0, 1. 0, 1 means this is the M register, and now it will come here, incrementing the H, then M becomes 0, 7. Now again comparing, 0, 1 and 0, 7 are compared, no carry, then it is going to loop 2. Now B becomes 0, 0. If it is 0, it is returning. It will come to the next statement and it will return, and here it comes. So now what we have to do is, we have to retain the old value. Now B becomes 0, 5 and HL becomes 4201. Now whatever the content of accumulator is available, that is copied to accumulator. What is the content of accumulator? That is 0, 1, the smallest number available in the array. It is available, then it is copied to M register. M register means 4201 is taking the value of 0, 1. Now we are decrementing B register. Now the B register is equal to 0, 4. It is not at 0, so therefore it will go to this location, and it is incrementing the H value. So 4201, you can see this 0, 2 was there. No, that 0, 2 is replaced with 0, 1. The 0, 1 was available in the third location, that becomes 0, 2. So this swapping was done now. So we are incrementing the H, then H, the memory pointer goes to this 5, 0, 5. Again we are repeating the same process. Then what will happen? 0, 1 comes here, no? 0, 2 is stored here, 0, 3 is stored here, and then 0, 5 will be stored here, 0, 7 will be stored here, and then 9 will be stored in the last memory location. So the process is repeated again and again. Now you can understand what is the significance of pushing the H and B value into the stack pointer, so that this process is repeated. First time it is running for 5 times, second time only 4 comparisons are required, third time only 3 comparison, fourth time only 2 comparison, fifth time only 1 comparison is required. After that we are decrementing, then the B register becomes 0. So which means every time, first time we have done 5 comparison, second time it is 5 minus 1, 4 comparison, third time it is keep on increasing, keep on decreasing the number of comparison. Subsequently we are storing the number in the next memory location. That smallest number is stored in the first memory location. Next time the next smallest is stored in the second memory location. Third time the next smallest number is stored in the third memory location. It is keep on repeated. So if you want to repeat the same program in a descending order, so you have to change only one thing. So instead of jump carry, here you just type jump no carry. Then instead of a small number which is stored here, the larger number will be stored in the first location. Again the same procedure will be repeated. I hope you will understand this program. If you don't understand, please work out the program on your own based on the instruction given here. Try to simulate in the simulator and execute in a step-by-step mode. Definitely you will understand. Even after that, if you have some doubt, you can ask me in the comment box. I will answer all the questions. Thanks for listening. See you in the next video.